Good afternoon. My name is Juan Leal. I'm from Medellin, Colombia, as already said. I work in Gaia Environmental Service, and today I want to share with you our experience in product carbon footprint in Colombia. Yes, we work in carbon footprint in Colombia too. First, let me tell you about Gaia. Gaia is a consultant firm that serves the largest companies in our country in their way to sustainability. We are certified as carbon footprint expert by Carbon Trust. We have a cooperation agreement with IFU Hamburg, developers of the software Humberto Carbon Footprint. And we also have an agreement cooperation with South Pole Carbon brokers and project developers. We also members of the LCA Ibero-American Network. As I said before, we work with the largest companies in our country. This is some of our experience in carbon footprint. We've been working in chemical resins. That is the issue from today. Cookies and crackers, lighting and illumination, plastic packagings, chocolate, sausage, flowers, ethanol from cassava, and many other products. Our client, the chemical manufacturer, is named Grupo Mundial. Grupo Mundial is a Colombian multinational group focused in Latin America. One of the companies of this group is Undercoal, is a chemical manufacturer. They make resins between other products. And today I'm going to show you about the carbon footprint of these resins. Well, please let me tell you some facts about unsaturated polyester resins, or UP resins. There are many kinds of these resins, but for today we are going to focus on dicyclopentadiene, or DCPD resins. They have many uses. We find it everywhere in our lives, like in the automobile construction, the building industry, and the boat construction, pipes, and many other products. Well, the problem with the resins with DCPD, or dicyclopentadiene, first and all, is an important market for unsaturated polyester resins. World production is about 200,000 tons per year, while DCPD resins world production is about 30,000 tons per year. And dicyclopentadiene have many problems, as just like a highly flammable liquid, is toxicity from inhalation and ingestion, causes eye irritation, skin irritation, and is a water pollutant. One main thing to remark here is that Undercoal does not use DCPD in their resins. Undercoal has developed a new technology in the production of resins. Some important characteristics of the green resins are low viscosity and high solids. That's what the customers look for. Use at least 25% of renewable material. Uses at least 25% of recycled material. Mimics the characteristics of DCPD resins, or act just the same as DCPD resins. Use a chemical compound that have low toxicity, low odor, low volatility, non-flammable, and is renewable. Well, the methodology that we use is PIS 2050. The scope was business to business because these resins are used in other companies to make other products. The year was 2011. We studied all the greenhouse gases. We got primary data from the mass and energy balance for the production plant. We got secondary data from raw materials from Equinvane 2.2. We use the software Umberto Carbon Footprint 1.2 for the calculations, and of course, we apply the product category rules of paints, varnishes, and related products of EPD. Well, let me tell you about the product carbon footprint of these green resins. First, we find in Equinvent the polyester resin have a product carbon footprint of 7.47 kilograms of CO2 per kilogram. But we focus on DCPD resins, as I said before, and we find in a study of McCarthy 2010 that shows the product carbon footprint of these resins are about 4.2 kilograms of CO2 per kilogram. That's the one we are going to compare with the green resins that Undercoals made. Well, the green resin of Undercoal reduced 40% of the product carbon footprint when we compare with DCPD resins. I'm going to show you why. Well, this is the main product carbon footprint. As we can see here, raw materials account for 92.2% of the carbon footprint, while the chemical plant contributes in 7.6%, and the indirect emissions given for waste disposal is less than 1% of the product carbon footprint. When we look at the raw materials, we can see that renewable materials is only 0.2% of the impact. Recycled material is about 7% of the impact, and other ingredients are 92.9% of the impact. Looking at the manufacture, we can see that direct greenhouse gas emissions for the use of gas are about 36.8% of the contribution. Electricity, 16.8%, and other components gives 46.3% of the impact. The world production of DCPD resins is 30,000 tons per year approx. If all the DCPD resin was changed to green resin, we could avoid the emission of 50,000 tons of CO2 per year. Well, one of the main components of the UP resins, or unsaturated polyester resin, is the phthalic anhydride. That has a big product carbon footprint of 2.55 kilograms of CO2 per kilogram. That is a data from Equinvent. The phthalic anhydride used in Undercoal is produced in the main factory. They produce his own phthalic anhydride, and in the process is an exothermical reaction. They use this heat to other processes in the factory, so they reduce the carbon footprint of the phthalic anhydride and 30% mostly. When we talk about renewable materials, we must refer to two important issues in the carbon footprint: carbon sequestration and land use change. Carbon fixation or sequestration in short-life crops is not significant, whereas land use change may have a greater importance. In the case of Colombia, according to the calculation of the greenhouse gases inventory by the United Nations, there is that land use change is responsible for 13% of the country's emissions, and 9.2% of this is due to the change of forest to grassland. Yes. And looking at the apport of energy to the carbon footprint, we can see for Colombia, the installed capacity is about 63% from hydropower, while 31% is from thermal energy. This is because Colombia has the perfect climate and relief for the construction of large dams for hydroelectrical power production. Sorry. Sorry, esto no me baja. No me baja el... Well, but the important thing is that I need to load down this, please. Yes, es que no sale entero. You have to. Yes. Considering the actual generation for 2011 in Colombia, we have generated electricity by 78% with hydropower and 16% with thermal. As we know, thermal energy have greater carbon footprint than hydropower. For this reason, the electricity in Colombia have a low contribution of the carbon footprint in the resin. Talking about the emission factor for the electricity generation in Colombia is related to the climate, mostly the precipitation. As you can see in the graph, when La Niña phenomenon comes, we have more precipitation, and we don't need to use too much thermal, so the emission factor is going down. But when El Niño phenomenon comes, we have less rain, less precipitation, then the emission factor rise. And then comes La Niña again, and we have more precipitation, so we don't need to use too much thermal, and the emission factor is low. This is some electricity emission factors of different countries. I just want to show that the emission factor for electricity in Colombia is low. Maybe other countries have a lower emission factor, but manufacture political problems makes Colombian production better or easy for this case. Well, in conclusion, the green resins provide a lower product carbon footprint and environmentally friendly applications. According to the Ecoembane database, the product carbon footprint for polyester resin is 7.47 kilograms of CO2 per kilogram. It's higher than the product carbon footprint calculated for this resin produced by Undercoal. And when we compare this green resin with DCPD resins in Ecoembane, we can find that we reduce the carbon footprint by 40%. The product carbon footprint is an indicator of the environmental impact of the product associated with greenhouse gases, but does not represent the total environmental impact of the product. So to have the complete assessment, we need to do a life cycle assessment complete. Yes? Oh no. Well, this is the question that this is the big question that I need to answer now. What would be the most powerful step forward to drive reductions in climate and environmental impacts in products and value chains? Well, as you know, the product carbon footprint is a very technical concept, and the common people may understand too late the real impact of the products that they use. So the most powerful step to drive a reduction in climate and environmental impacts in product and value chains will be policy of the governments, regulations, like carbon footprint labels. Besides, they can invite different industrial sectors to have taxes, benefits, or instead applying more taxes. I don't like that, but maybe it's the way to do it. Also, promoting education campaigns related to climate change so that people have the right information to make decisions when purchasing goods. Well, Thank you very much. Gracias.